Hi guys, Mr. Kane here. Good to see you again.
Hi, Mrs. G. Here I am again. Mr. Kane, there's an animal on your board.
There's an animal. Oh, we have to call animal control.
Animal control. What is that, Mr. Kane?
I don't know. I think that's yours, Mrs. G. Don't you have a name for her?
Let me put my glasses on. That's Millie. That's Millie the mole. How'd you end up with her?
Millie the mole?
I thought I'd lost her.
Well, she's very small, so,
Yeah.
being named Millie.
It's hard to see her sometimes. She's so tiny.
All right, so we're starting out here with the mole concept. And just in case you guys were wondering, there is a date coming up. October 23rd is National Mole Day.
And why is it on the 23rd of October, Mr. Kane?
Because in chemistry, we use this number, 6.02 times 10 to the 23rd, to express what a mole is.
All right.
And October 23rd, 1023.
Clever.
So, yeah, it's, you know what, the math people have Pi Day, we have Mole Day.
Okay.
Yeah.
All right. Goals of Unit 7. Understand the concept of the mole and why it is important to chemists. Be able to determine the molar mass of a given substance. Be able to use Avogadro's number in mass, mole, liter, and particle conversions. Ooh, that sounds like math.
Mm-hmm.
Be able to use laboratory data to determine percent composition, empirical formula of a compound, and molecular formula of a compound. And that sounds like math, too.
Ooh, it's math. Do I need a calculator?
You need a calculator.
I actually don't. I can do the math longhand. I prefer not to, but...
I would advise a non-graphing calculator. You'd be amazed at what can be programmed into those graphing calculators.
All right. So, to start out with, the mole. The mole is a unit. It's an SI unit for counting by measuring. It's kind of an interesting concept. We count by measuring. So, because we're measuring, there is significance.
Okay.
But we're using the measurement to actually count. It comes from the old Latin root word meaning small piles. So if you've ever wondered why it's called a mole, it's a small little pile of things. And if you think about it, moles themselves, the animal, make small piles on your lawn.
Yeah, that's true.
So maybe that's why they call them moles in the first place.
Yeah.
The only acceptable abbreviation for mole is MOL. Okay, you cannot use the letter M because the letter M stands for meter.
Yeah, meters got to it first.
So mole is MOL. Okay, it is a counting unit. If you're familiar with the idea of a dozen being 12, then you should be familiar with the idea of a mole. 1 mole is equal to 6.02 times 10 to the 23rd things. And I probably should actually have labeled this as 12 things.
Yeah.
If I go to the store and buy a dozen eggs, I've got 12 eggs. If I buy a dozen shoes, I've got 12 shoes.
So the mole has a certain quantity to it.
Mm-hmm.
And if we tell people we want 1 mole of something, they know what we mean.
Chemists will know what you mean.
Chemists will know.
Or people who
So,
took chemistry.
If I had to make an analogy, I would have to say, other than the dozen works good too, but like, wouldn't that be kind of like a loaf of bread too? A loaf of bread has a certain number of bread.
Oh, a certain number of slices.
Slices, yeah.
Mm-hmm.
So instead of asking your grocer for 3 slices of bread, you just go in there and buy a loaf.
Right, exactly. Okay.
That's easy.
Okay. So why is it that chemists don't count atoms in dozens like everyone else counts dozens, dozens of eggs and things like that? It turns out that atoms and molecules are so extremely small that a 12-ounce bottle of water, that's 355 milliliters for those of you in the metric zone, would have 1.19 times 10 to the 25th molecules of water. That's molecules, okay? So if we try to count that in dozens, the math works this way. We'd take 1.19 times 10 to the 25th molecules, and we'd say that 12 molecules is a dozen, and we'd wind up finding out that in terms of dozens, it has 9.89 times 10 to the 23rd dozen molecules.
That's a tough number to say, to write.
It's still way too many to say and write.
Yeah, I mean, I'd probably mess it up and drop a number or put 22 down when it should be times 10 to the 23rd. That's an ugly number.
Not to mention, even if you can remember that and say it,
who
really wants to?
Yeah,
okay?
I'd rather not.
All right, so 9.89 times 10 to the 23rd dozen water molecules just doesn't swing it for chemists. We're lazy. We don't want to write that much or think that much.
Gotta be an easier way.
All right, so the number's impractical. So what we do is we use this idea that a mole is 6.02 times 10 to the 23rd particles. Okay. What that means is that the number looks like this, and we've written that number before in class in the last unit.
We just did that with the questions from the video, third video. That was one of the
All right.
questions.
So if we measured a mole of donuts, it would be 6.02 times 10 to the 23rd donuts. So if I wanted a mole's worth of donuts to celebrate National Mole Day, I would call up Dunkin' Donuts and I'd say, hi, I want to order a mole of donuts.
And 6.02 times 10 to the 23rd donuts would be delivered to you?
Well, I think I might get laughed at because it's a lot of donuts.
That's a lot of donuts.
All right. 1 mole of atoms would be 6.02 times 10 to the 23rd atoms.
Okay.
A mole of molecules would be 6.02 times 10 to the 23rd molecules. What this means is if we do the math, a 12-ounce bottle of water would have 19.7 moles of water in it.
And that's a much nicer looking number than 9.89 times 10 to the 23rd.
Oh, heck yeah.
That's
a lot. Yeah.
nice, aesthetically pleasing number.
I'm actually impressed that you remember that number because I've completely forgotten it already. 19.7 is much easier.
What does 1 mole look like? Well, it depends on the substance. So sulfur, zinc, iron, water, sodium chloride, and lactose are all different substances, but they'd each have the same number of particles that make them up in a mole. They'd all contain 6.02 times 10 to the 23rd particles. Oh, and each 1 mole of each substance, because I see a couple of elements and some compounds, yeah?
So
I see 3 elements.
So an element I'd speak of in terms of atoms, right?
So the smallest single unit in an element is atoms.
Atoms, atoms, and atoms.
Yeah. And then water is H2O, and that's right-hand side of the periodic table. That's a molecular compound.
Molecules.
Molecules. Single smallest unit is a molecule.
Uh-huh.
And the single smallest unit of an ionic compound is usually called formula units.
Formula units.
Would strongly advise not abbreviating that to
Ooh.
FU.
Yeah,
I would say
yeah,
no.
probably not. Okay.
Form U's would be fine, but not FU.
All right. Form use.
Form U's, yeah, I'd
Okay.
go with that. Lactose.
Lactose is
It's an organic,
it's
isn't
an
it?
organic, so we'll call it a molecule.
Okay.
Okay, mostly
So
non-metals.
tiny little pieces. Okay.
So we can throw up some pictures of what 1 mole looks like of each of these.
Awesome.
Okay.
Counting small particles.
This is the same.
This is the same thing,
Yeah,
isn't it,
it's
Mr.
the same
King?
thing
An
in other-
element
in-
has atoms in it. Ionic compound is a formula unit. You should know what an ionic compound is and looks like and named.
That's type 1 and 2 for those
Yes.
of us who don't remember. Yeah.
And a molecular compound is molecules.
That's type 3.
And ions are ions. Okay.
Ions are ion. Yeah, those are the charged things, right?
Yep. Measuring a mole of small particles. Same quantity of particles, different names, which we've just gone over 3 times now,
Yeah, 6.02 times 10 to the 23rd. Atoms would be a mole of copper.
which is an element.
Yeah. A mole of sodium chloride would be
Ionic
measured
compound.
ionic compound, so we got a metal and a non-metal, so formula units. 2 non-metals, so molecules. And the charge, so
Ions. Okay, so 1 mole of any substance is equal to 6.02 times 10 to the 23rd pieces of that substance.
yeah, atoms, formula units, molecules, ions, these are pieces.
So if I wanted to buy Pixies and caramel pieces, I could get a mole of Pixies and a mole of caramel pieces, and both of them would contain 6.02 times 10 to the 23rd pieces.
Yeah, pieces.
Pixies.
Pieces,
Ooh,
pieces, yeah.
that I would like.
Speaking of pieces, I would love a mole's worth of Reese's.
Yep, there you
Pieces.
go. That would be lots and lots, but that'd be awesome.
That'd fill a swimming pool at least. Okay, so who came up with the idea of a mole? It turns out that this guy, Amedeo Avogadro, figured it out in 1811. He was the Count of Quargna. He's an Italian. And he also happens to be a savant, which means that he's really, really good at certain things. Some savants are good at music, some are good at math. He's good at math. And he is the guy who came up with the idea that a certain amount of a substance should be equal to the same number of particles. Okay, the idea which we now call Avogadro's number,
Avogadro's
which Avogadro's number is, again,
6.022.
6.02 times 10 to the 23rd atoms. Now, Ms. G, I heard you call it 6.022.
Yes.
I know that honors uses 6.022, but you know we're in
Sorry.
regular chemistry, so we'll use one less digit just
Okay.
for fun.
All right.
And if any of our students ever want to take honors or AP, they'll realize that
Yeah.
the number might change a little bit, depending on how precise they want their values to be.
Okay.
3 is good enough for us. How big is a mole?
How big is a mole, Mr. King?
I love this part. Okay.
1 mole of hockey pucks would equal the mass of the moon.
Yeah. So
Wow.
that's heavy stuff.
Yeah. 1 mole of basketballs would fill a bag the size of the Earth. Boy, that's an interesting vision.
Yeah, I mean, you got a
Whoosh.
huge, yeah.
A mole of pennies would cover the Earth a 1/4 mile?
A 1/4 mile deep. Okay, so
Whoa.
we're talking about a lot of pennies
yeah,
there.
that's a lot of quantity. That's a big number.
And that's not the Chicagoland area. That's not the United States. That's the Earth.
The entire Earth.
The entire
all
Earth.
the way around, covered a 1/4 mile.
Including-
1/4 mile.
Including the water.
Man.
And a 1/4 mile is at least the distance from here to my house.
So Avogadro's number is very big.
Yeah, it's extremely big. That's a lot of stuff. And a mole of seconds is the one that's incomprehensible to me. A mole of seconds is 4 million times longer than the Earth has existed.
Oh my. That's
Okay.
interesting.
So the Earth hasn't even existed for a mole's worth of seconds.
Wow.
It hasn't even existed for a millionth of a mole.
Holy cow.
It's a 1/4 of a millionth of a mole in seconds.
All right, example number 1. How many molecules of water are in 1.25 moles? I bet we could do a conversion
Yeah.
factor dimensional analysis for
Yeah,
this.
I think we can.
Okay, start with the number in the problem.
Start with the moles.
1.25 moles.
And we want to find molecules.
Okay, so we have to create a conversion factor from Avogadro's experiment stating 1 mole is 6.022 times 10 to the 23rd molecules. So which would go on the top and which would go on the bottom of my ratio?
Well, I've got moles on top, so I think I want moles on the bottom.
All right, and the definition is 1 mole.
All right. And I want molecules on top.
And what molecules on top? All right.
So the definition is 1
1
mole is
6.022. I'm sorry. 6.02 times 10 to the 23rd molecules. Now, is it written right, Mr. King? Moles cancel? Yep.
All right, let's check. Yeah, moles cancel.
Awesome.
So let's see. Moles cancel with moles. And we wind up with molecules. We do a little math. Punch it into your calculator. 1.25 times 6.02 times 10 to the 23rd. And you get
7.53 times 10 to the 23rd with 3 sig figs, just like in the problem.
3
Awesome.
sig figs. Now, Miss G, when I'm looking here, I can see 3 sig figs here. How many sig figs are in the number 1?
Undefined.
Undefined, so infinity.
Yeah,
All right.
infinity.
How many sig figs in this number?
It's an infinite number because it is a conversion factor.
Okay.
So it will not determine how many significant figures are in your answer. Just like before, the conversion factors don't.
All right, so 3, and I've got
3.
3 here. Okay, that sounds simple enough.
All right, that works. How many moles are equal to 2.8? Now we're going backwards, aren't we?
Yeah. Now, if you feel good, if you feel up to this, pause and try it out yourself. Okay. We're moving forward here.
Now the setup, always start with the number in the problem, which in this particular case is the 2.8 times 10 to the 22nd molecules.
All right.
Which you wrote down, Mr. King, very well, numerical value and unit.
Thank you. Thank you very much.
You are welcome.
Over on the right here, we write moles of water.
So that's where we're heading, is moles of water. So we need a ratio, which that is, and we need to write the ratio appropriately so that molecules cancel.
Well,
right?
last time we put moles on the bottom.
Oh, well, we do that this time too then,
Yeah,
right?
yeah, put moles on the bottom here,
Okay.
and moles will cancel with molecule.
Oh.
But the word moles in it, so I'll cancel mole, and I'll
then
get
you'll have
cules
cules?
times molecules.
That would be molecules squared.
Yeah,
No, don't think so,
yeah.
Mr. Kane.
Okay, so-
molecules must cancel.
So molecules on the bottom,
Yep, I would go with molecules on the bottom so
All
that
right.
they cancel.
and moles on top then.
Yep, beautiful following just the units.
And according to the definition, 6.02 times 10 to the 23rd molecules on the bottom,
Yep,
and 1 mole on top.
yep.
Yeah. Okay. So then we check the units. The molecules do cancel with the molecules. And the math becomes 2.8 times 10 to the 22nd divided by 6.02 times 10 to the 23rd.
Yep.
And there we go.
0.0472 sig figs, just like the 2.8 times 10 to the 22nd.
Yeah, once again, two sig figs in this number.
Yep.
Infinity over here,
Yep.
and infinity over here, so undefined, as you say.
Yep.
So we want 2 over here also. Okay, simple enough. homework.
Ooh.
All right, now guys, very careful here. Listen to the instructions. You must write the title, Homework Mole 1, on top of the sheet of paper.
No work, no points.
There we go. Everyone, yeah, show your work.
No work, no points.
How many formula units are equal to 12.62 moles?
Okay, so
should be able to do that.
Yeah, converting. Okay.
All right. Okay.
Sounds good.
So see you tomorrow. Bring this to class. Turn it in with your name on it.